So now we'll discuss lattice, crystal lattice or space lattice. Crystal lattice or space lattice. It can be denoted by one diagram, but it is not asked in any of the examination. Just for understood purpose, we will draw this diagram of a solid. How the crystal lattice is represented. Now I will take, this is a cube. Each face center point is joined. Each face center point. Next, this point. And next, this point. Okay. Now we have to join this point and this point. And next is the center point. Here, in this diagram or solid, I will represent the dots, various dots. Okay. In such dots or in such diagram, again I will represent one simple cube. This portion what it represents, it represents one simple cube. Like this cube, there are various cubes are arranged in this lattice. So, crystal lattice or space lattice meaning is said to be the arrangement of constituent particles. Constituent particles in three-dimensional space. The arrangement of constituent particles in three-dimensional space, that is known as crystal lattice or space lattice. What are the characteristics of this space lattice? Or before that, how many crystal lattices are there? There are totally 14 crystal lattices are there. These 14 crystal lattices are possible. Such 14 crystal lattices are named as, one scientist named Bravais lattice. Bravais lattices. many Bravais lattices? 14 crystal lattices are known as Bravais lattices. Okay. Under 14 ಪಾಸಿಬಿಲಿಟಿನಲ್ಲಿ ಈ ಥರ ನಾವು ಕ್ರಿಸ್ಟಲ್ ಲ್ಯಾಟೈಸಸ್ಗಳನ್ನು ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಬೋದು. ಅದಕ್ಕೆ ಬ್ರವೈಸ್ ಲ್ಯಾಟೈಸ್ ಅಂತೇಳಿ ಮೆನ್ಷನ್ ಮಾಡ್ತೀವಿ. ಸೊ ವಾಟ್ ಆರ್ ದ ಕ್ಯಾರೆಕ್ಟರ್ಸ್ ಆಫ್ ಕ್ರಿಸ್ಟಲ್ ಲ್ಯಾಟೈಸ್ ಆರ್ ಸ್ಪೇಸ್ ಲ್ಯಾಟೈಸ್? ಫಸ್ಟ್ ಪಾಯಿಂಟ್ ಈಸ್ each point in the lattice represents lattice point. Or you can take it as space lattice. Second point is lattice points are constituent particles. Constituent particles means they may be ions, atoms or molecules. And next point is, if you join these lattice points, they gives a definite geometry of the crystal. Or joining those lattice points in straight lines, we are getting one perfect geometry, that is nothing but crystal lattice or space lattice. ಇದನ್ನು ನಾವು ರೀಪ್ರೆಸೆಂಟ್ ಮಾಡಿದ್ದು, ಇದರಲ್ಲಿ ಸಾಕಷ್ಟು ಈ ಥರ ಏನಿರ್ತಾವೆ ಅಂತಂದ್ರೆ ಸ್ಮಾಲ್ ಪೋರ್ಷನ್ಸ್ ಇರ್ತವೆ. ಇದನ್ನು ನಾವು ನೆಕ್ಸ್ಟ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತೀವಿ. ಬಟ್ ಯು ಕೆನಾಟ್ ಪ್ರಾಕ್ಟಿಸ್ ದಿಸ್ ಡಯಾಗ್ರಾಮ್, just for observe what portion is there. There is a simple cube. Okay, so this portion is known as one small portion of the complete lattice, space lattice. Okay. The arrangement of particles in three-dimensional space. Particles means atoms, ions or molecules. Simple characters. One is whatever the points, they are called as lattice points. Lattice points are nothing but constituent particles. Whereas you join in straight line these constituent particles, what happens? You will get a perfect, definite crystal lattice. So come to know that small portion, what it indicates, or what is the name of that small portion? It is called as unit cell. Unit cell. You can represent very clearly that small portion. This type of diagrams are important. Okay, this is a simple cube, or you can say that it is unit cell. This lines represented are seen to be edges A, B and C. If you take between A and B, it is known as alpha. It is edge edge length, and this is bond angle. Between B and C, beta. Between A and C, it is known as gamma. ಈ ಥರ ಇರ್ತದೆ. Somewhat important definition. What do you mean unit cell? This is smallest portion of the crystal lattice. Already we have represented smallest portion of the crystal lattice, which when ರಿಪೀಟೆಡ್, ಇದನ್ನೇ ಸ್ಟ್ರಕ್ಚರ್ ರಿಪೀಟ್ ಆಗ್ತಾ ಹೋಗ್ತೈತೆ ಅದರಾಗ ಕ್ರಿಸ್ಟಲ್ ಲ್ಯಾಟಿಸ್, ವಿಚ್ ವೆನ್ ರಿಪೀಟೆಡ್ ಓವರ್ ಆ್ಯಂಡ್ ಅಗೈನ್, ಮೇಲೆ ಹಂಗೆ ಅದನ್ನು ರಿಪೀಟ್ ಆಗ್ತಾ ಹೋಗ್ತೈತಿ. ಅಂದರೆ ಇಂಥವು ಸಾಕಷ್ಟು ಅದ್ರಾಗ ಸೇರಿ ಒಂದೇನಾಗಿರ್ತೈತಿ ಕ್ರಿಸ್ಟಲ್ ಲ್ಯಾಟಿಸನ್ನು ಆಗಿರ್ತೈತಿ. ವಿಚ್ ವೆನ್ ರಿಪೀಟೆಡ್ ಓವರ್ ಆ್ಯಂಡ್ ಅಗೈನ್ generates a definite geometry, generates a geometry of the crystal lattice, So it is nothing but crystal lattice ತೆಗೆದು ಸ್ಮಾಲ್ ಪೋರ್ಷನ್ ಅಂಥವು ಸಾಕಷ್ಟು ರಿಪೀಟ್ ಆಗ್ತಾವೆ ಮೇಲೆ ಓವರ್ ಆ್ಯಂಡ್ ಅಗೇನ್. ಆ್ಯಂಡ್ ಏನು ಕೊಡ್ತೈತೆ ಒಂದು ರಿಪೀಟ್ ಆದಮೇಲೆ ಒಂದು ಜಾಮೆಟ್ರಿಯನ್ನು ಕೊಡ್ತೈತಿ. ಆ ಜಾಮೆಟ್ರಿ ಯಾವುದು? ಕ್ರಿಸ್ಟಲ್ ಲ್ಯಾಟಿಸ್. ನಾವು this unit cell has two important parameters. The parameters are first one is edge length. They are denoted by symbol A, B and C. Second is angle between the edges. Angle between the edges. The angles are denoted by alpha, beta and gamma. Okay, so this is somewhat important. Now we will discuss, there are different classes of this unit cell types. Mainly they are classified into three types. First one is called as primitive unit cell, and second is known as centered unit cell. Primitive means simple cube. Primitive unit cell, centered unit cell. Centered unit cell is again taken into different classes. One is known as body centered. Second is face centered. Third is end centered. Three different classes of centered unit cell: body centered, face centered, end centered. Okay, so primitive I will represent one small diagram, simple cube. This is known as primitive. Okay, simple cube. If you come to know body center, again I will represent one simple diagram here. First you have to draw simple cube. At the center of the body there is one constituent particle known as body centered. Face centered, if you take again simple cube, each faces, there are totally 6 faces. 1 face, 2 face, 3 face, and this is 4. This complete is known as one face. At this center, 1 point, and this complete is known as one face at the center of this. ಅಂದ್ರೆ 6 ಫೇಸಸ್ನಾಗ ಒಂದೊಂದು ಡಾಟ್ ಇಟ್ಟಿದ್ದೈತಿ, ಅದಕ್ಕೆ ನಾವು ಏನಂತ ಕರಿತೀವಿ? ಫೇಸ್ ಸೆಂಟರ್. ಎಂಡ್ ಸೆಂಟರ್, ಎಂಡ್ ಯಾವುದಾದ್ರೂ 2 ಫೇಸಸ್ಗಳು, ಈ ಫೇಸರ ಅಪೋಸಿಟ್ ಫೇಸಸ್ಗಳನ್ನು ತಗೊಳ್ಳಿ, ಅದರಾಗ ಒಂದು ಡಾಟನ್ನು ರೀಪ್ರೆಸೆಂಟ್. ದಿಸ್ ಈಸ್ ಅಪೋಸಿಟ್ ಟು ಈಚ್ ಅದರ್, ಅಥವಾ ಇದ್ರದ್ದು ನಿಮ್ಗೆ ಅಪೋಸಿಟ್ ತೊಗೊಂಡಿದ್ರೆ ಅಲ್ಲಿ ನೀವು ಪಾಯಿಂಟ್ಸ್ನ ರೀಪ್ರೆಸೆಂಟ್ ಮಾಡಿದರೆ ಎಂಡ್ ಸೆಂಟರ್ಡ್ ಅಂತೇಳಿ ಕರಿತೀವಿ. ಸೊ ದೀಸ್ ಆರ್ ನಥಿಂಗ್ ಬಟ್ ದ ಟೈಪ್ಸ್ ಆಫ್ ಯೂನಿಟ್ ಸೆಲ್ಸ್. ಮೇನ್ ಟೈಪ್ ಈಸ್ ಪ್ರಿಮಿಟಿವ್, centered. Primitive is simple cube. Centered means in that simple cube you are arranging the constituent particles at the body known as body center, at the faces known as face centers, at the ends of two opposite faces known as end center. Okay. So such class of unit cells we have discussed. You have to just observe the simple diagrams. ಸಿಂಪಲ್ ಕ್ಯೂಬ್ ಒಂದೊಂದು ಗೊತ್ತಿತ್ತಂತಂದ್ರೆ ಮುಂದೆಲ್ಲ ನಾವು ಅದನ್ನು ರೀಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾ ಹೋಗ್ಬೋದು ಅಕಾರ್ಡಿಂಗ್ ಟು ದೇರ್ ವರ್ಡ್ಸ್. ಬಾಡಿ ಮೀನ್ಸ್ ಬಾಡಿ ಆಫ್ ದಟ್ ಕ್ಯೂಬ್, ಫೇಸ್ ಸೆಂಟರ್ಡ್ ಮೀನ್ಸ್ ಈಚ್ ಫೇಸ್ ಡಾಟ್ಸ್, ಎಂಡ್ ಸೆಂಟರ್ಡ್ ಮೀನ್ಸ್ ಅಪೋಸಿಟ್ ಪಾರ್ಟ್ಸ್. ಎಸ್, ಕಮ್ ಟು ನೋ ದೇರ್ ಆರ್ 7 basic unit cells. Basic unit cells. Primitive or basic or simple. Primitive. 7 primitive unit cells and their variations along different directions. ಎಡ್ಜಸ್ಗಳು ಯಾವ ಥರ ಇರ್ತಾವೆ, ಆಮೇಲೆ ಆ್ಯಂಗಲ್ಸ್ಗಳು ಯಾವ ಥರ ಇರ್ತಾವೆ ಅಂತೇಳಿ ನೋಡೋಣ. ಫಸ್ಟ್ ಒನ್ ಈಸ್ ವಿ ಹ್ಯಾವ್ ಟು ಟೇಕ್ ವಾಟ್ ಟೈಪ್ ಆಫ್ 7 primitive cells. And next is edges. So possible variations. Possible variations. Next is axial distances or edge lengths. Edge lengths, axial angles, between the edges, and last point is examples. This is somewhat for competitive examination, it is not for theory. Theory ಯಾವುದೇ ಟೈಪ್ ಆಫ್ ಕ್ವಶನ್ಸ್ ಕೇಳೋದಿಲ್ಲ. ಇವತ್ತು we will know what type of 7 primitive unit cells are there. First one is 7 ಒಂದು ಸಿಂಪಲ್ ಆಗಿರ್ತಕ್ಕಂಥ ಫಾರ್ಮುಲಾನ ರೆಡಿ ಮಾಡ್ಕೊಳ್ಳೋಣ. COTT, ಎರಡು ಟಿ ಟಿ ಬರ್ತಾವೆ, ಆಮೇಲೆ HRM ಎಷ್ಟಾಗ್ತೈತಿ ಇಲ್ಲಿ HRM ಅಂತಂದು ಗೊತ್ತಾಗ್ತದೆ. ಇದು ಕಾಟ್ 1 2 3 4 5 6 7. ಅದಕ್ಕೆ 7ಕ್ಕೆ ಏನಂತಂದ್ರೆ ಕಾಟ್ ಅಂತೂ ನಾವು ಗೊತ್ತಾಗ್ತದೆ. ನೆಕ್ಸ್ಟ್ HRM ಹ್ಯೂಮನ್ ರಿಸೋರ್ಸ್ ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ಅಂತ ಹೇಳಿ ಕರೀಬೋದು. ಸೊ ಕಾಟ್ ಮೀನ್ಸ್ ಕ್ಯೂಬಿಕ್ ಯೂನಿಟ್ ಸೆಲ್. ನೆಕ್ಸ್ಟ್ O ಆರ್ಥೋ ರೋಂಬಲ್. Orthorhombic. Next is tetragonal. So the next variations salagi space ಮಾಡಿಬಿಡೋಣ. ಇಲ್ಲಿ 4 ಟೋಟಲಿ ಅದನ್ನ tetragonal. ಇನ್ನೊಂದು ಟಿ triclinic, triclinic. Next I will do H, hexagonal, hexagonal, and next is R, rhombohedral, rhombohedral, and last is monoclinic, monoclinic. ಈ ಥರ ನಾವು 7 primitive ಯೂನಿಟ್ ಸೆಲ್ಸ್ಗಳನ್ನು ರೀಪ್ರೆಸೆಂಟ್ ಮಾಡ್ಬೋದು. ಆರ್ಟ್, HRS. C means cubic, orthorhombic, tetragonal, triclinic, hexagonal, monoclinic and monoclinic. Cubic na ಏನಿರ್ತೈತೆ ಅಂದ್ರೆ primitive cell. Only one. Primitive or simple cube. Orthorhombic. Here primitive is common, the main basic cube is common. Primitive. Next is body center. Body center, face center. ನಾಲ್ಕು ಇರ್ತವೆ. ಯೂನಿಟ್ಸ್ ಅಂತ 4 ಪಾಸಿಬಿಲಿಟಿ. ನೆಕ್ಸ್ಟ್ ಎಂಡ್ ಸೆಂಟರ್. ಓಕೆ, tetrahedral, primitive is name and body center. Triclinic, only primitive. Hexagonal, here also only primitive. Rhombohedral, primitive. Last is primitive and end center. Primitive and end center. Okay. Edge length. Edges ಅಂತಂದ್ರೆ ಏನು ರಿಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀವಿ? A. Length is equal to B. Length is equal to C. In case of orthorhombic, edges are not equal to each other. A is not equal to B is not equal to C. In tetragonal, A is equal to B is not equal to C. Next is A is not equal to B is not equal to C. Hexagonal, A is equal to B is not equal to C. Rhombohedral, all are equal. Monoclinic, A is not equal to B is not equal to C. So if you go to the diagrams of all these, those ends are H lengths are said to be denoted. The diagrams are again important. Let it be the types and possible variations. Axial angles. What are axial angles? Alpha is equal to beta is equals to gamma. It is the case of all cubic, tetrahedral or the rhombic. Alpha is equals to beta is equals to gamma. Alpha is equals to beta is equals to gamma. Alpha is equals to beta is equals to gamma. It is 90 degree. Okay. COT, triclinic, is also same. Alpha is equal to beta is not equal to 90 degree. Alpha is equals to beta, but beta is not equal to gamma. Alpha is equals to beta, beta is not equal to 90 degree. What about gamma? Sorry. Beta is equals to gamma, not equal to 90 degree. And remaining is hexagonal. In this case, hexagonal. Alpha, beta are 90, gamma is 120. They are said to be 90 degree, but gamma is 120 degree. Rhombohedral. Rhombohedral. Alpha, beta, gamma, all these are not equal to 90. Not equal to 90. And last, monoclinic. Alpha, gamma 90, beta is not equal to 90. Monoclinic. Alpha equal to gamma is equals to 90, but beta is not equal to 90. ಈ ತರಹದ angles ನಾವು represent ಮಾಡಬಹುದು. So better you have to take one example for all these types of 7 classes. First one is sodium chloride. Second is calcium sulfate. First one is NaCl. Orthorhombic. Orthorhombic example is BaSO4. BaSO4. One example ತಗೊಳ್ರಿ. ಆಮೇಲೆ tetragonal calcium chloride. Calcium sulfate. Tetragonal is calcium sulfate. Triclinic is K2Cr2O7. Triclinic K2Cr2O7. Various examples are there. Hexagonal graphite. Hexagonal graphite. Rhombohedral. Rhombohedral calcite. Calcite is a ore of calcium carbonate, CaCO3 calcite. And next is monoclinic. For monoclinic, best example is you can take any of the mono atoms, sulfur or sodium sulfate, hydrated sodium sulfate. Sulfur or hydrated sodium sulfate. Hydrated sodium sulfate formula is Na2SO4 hydrated means 10 water molecules are there. For this example, monoclinic. So this is a table. It indicates 7 primitive unit cells and possible variations, as well gauge lengths, angles, examples. So, for competitive study, we will go through in detail this table. We'll continue next class.